Hello, Mr. Campbell. Thank you very much for taking the time to speak with me today. My name is Aaron Cohen, and I'm participating in a science fair. And I recently qualified for the AZSEF, which is the Arizona State Science Fair. And I've been deeply curious about the nature of consciousness for a while now. And your work makes a ton of sense when thinking about a universal consciousness. And when I discussed these ideas with several world-renowned physicists throughout this project, many of my questions were met with skepticism or even outright rejection. So along this path, I developed an MLHC theory, a multi-layered holographic impression, and wrote a research paper on it. Today, I'd love to discuss your work on consciousness and share my MLHC research with you.
Okay, well, in your little introductory note that you sent, you said that you were working on a kind of Hawkins theory of black holes and mapping the interior information to the outer surface.
Yeah.
And since that outer surface is reachable and so on, and trying to link that to consciousness. And it doesn't really work that way. A lot of scientists go that path because they start with an assumption that the physical world is fundamental reality, and everything is derived then from that physical reality. Well, that's called materialism, or more physicalism is actually the better philosophical term. That is a mistake. That's not true. It doesn't flow that way. But the reasoning that they have is that quantum physics is non-local, has non-local attributes, and consciousness has non-local attributes. Therefore, quantum physics is probably a good explanation for consciousness. And with that, with quantum physics, you get ideas like, things travel much faster than the speed of light when you have, what's the word I'm looking for? Entanglement is the word I'm looking for. When things are entangled, that's instantaneous. Okay? And that's a problem for physicists because things aren't supposed to be instantaneous. So they look at that and they come up with a couple of explanations. And one of those explanations has to do with information, because quantum physics has come to the conclusion, more or less, that the fundamental reality is information. And that's a fact, because they know that if they model, let's say, an electron as a little piece of mass with a charge, they can't get the right answer.
Yeah.
But if they model it as a point with the attributes of mass and charge, in other words, that's the way you model an electron in a computer, then they can get the right answer with quantum physics. So that tells us that information is more fundamental than mass. Information is more fundamental than the physical world. Now, the scientists want to link quantum physics and consciousness because they're both non-local. But that is not good logic. You could say, rockets fly and birds fly. Therefore, since they both have that same quality, then rockets must be birds, or birds must be little rockets. So just because you share a quality doesn't mean that there's any causality between the two. So the idea that consciousness is non-local and quantum physics is non-local doesn't logically imply any causality between the two. It remains just a possibility. And it's the only possibility that physics has, because quantum physics is the only thing that's non-local. And everyone knows that consciousness is non-local. So that's why we have this idea about information. And in order to explain the entanglement, they need a concept that information cannot be destroyed. Information always exists. And that's the fundamental idea that Hawking had when he talked about information in a black hole, map it up to the surface. The surface is something that you can connect with. So even in a black hole, information is preserved. This struggle to explain consciousness through quantum physics is not going to work, because the physical world is not fundamental. information is fundamental. And guess what? Consciousness is an information system. Consciousness is all about information. So that makes sense, because what are you conscious of? Well, you're conscious of what your five senses take in. That's information, input. Your five senses take in information. You take that information and you process it. What does it mean? How does this compare to the last time I looked? What's the significance of this information? Then you have memory, so you can compare it to what you remembered before, what's changed. And then you take all of that and you produce a choice. Okay, now that I know that, what do I do next? What's my response to this information? So that's consciousness. That's what your consciousness does. And if you didn't have your five senses, what would you be? You'd be a little point of consciousness with no sight, sound, taste, smell, touch. Just a point of consciousness. And I call that the Descartes moment. It would be, I am, therefore I exist. I exist, therefore I am. That's all you'd be, is a point of consciousness. So what do we know that takes in data, processes it, has memory, and with that memory and the processing produces a choice, an output? Well, that sounds just like a computer, doesn't it? So consciousness can be most accurately described as an information system. Now that works perfectly with quantum physics, who says, oh, reality is all about information. So those two come together. But the problem that one has with trying to start with the idea that information can't be destroyed, and also with the idea that the physical world, or the quantum physical world, is somehow, responsible for consciousness, that's starting at the wrong end. That's the tail trying to wag the dog. The fundamental thing is information. Consciousness is an information system. Consciousness is fundamental. The physical world then must be derived from consciousness. If the physical world is derived from consciousness, how could that be? Well, if you understand consciousness well enough, and I'm 80 years old now, so I've had a lot of time to study consciousness and to experiment with it. And my experimentation has told me that the only way that this can work is that if our physical world is computed by consciousness. So consciousness is an information system. So part of what I call the larger consciousness system can configure itself as a computer, and it can compute a virtual reality. And that virtual reality, to us avatars who are in it, looks perfectly physical. Because if you're an avatar in a virtual reality, from the avatar's viewpoint, your world is physical. It follows rules. The way you make a virtual reality is that you have a rule set and you have initial conditions. Then you punch the run button and those initial conditions change according to the rule set. Okay, now the initial conditions we started with was a tight ball of plasma, high temperature, high pressure, a small space. You recognize that as the Big Bang. But now this is a big digital bang. And the big digital bang is being computed on a computer. And just like the normal Big Bang, that ball of plasma expands, cools, forms suns, planets, all the rest of that stuff. And then eventually around the Earth, sun, we end up with biology and us. So that's all part of the evolution. Now, what if that whole evolutionary process took place in a computer and this was a virtual reality? Then you would have consciousness is fundamental, information is fundamental, your body is an avatar, and you are really a piece of consciousness. So that's kind of, in a very quick summary, that's kind of where I'm coming from, that consciousness is fundamental and the physical world is virtual. It's computed. Now, when you take that idea, there's a lot you can do with it. You can say, well, why does quantum physics work that way? Well, quantum physics isn't weird science. It's just a fundamental science once you understand this, because the way you compute a virtual reality is not from the ground up, from the small to the bigger to the bigger. You compute it statistically. It's thousands of times more efficient. And you can do that because at the bottom you have the rule set, which is more deterministic. And with that, you can compute the probability functions you need to describe the world. So ergo, the physical world is computed with probability and statistics. That's why quantum physics says the world is based on probability and information. So that explains that. Now, another big mystery to science is, why is the speed of light a constant? Well, if this is a grid, if it's a virtual reality, then as fast as anything can move contiguously through any virtual reality is 1 pixel of distance for 1 pixel of time. That's the speed limit. Otherwise, you'd have to jump like 10 pixels of distance for 1 pixel of time. Now you're teleporting. And that's kind of a crazy reality. So to have a nice button down reality, the fastest that you can go for contiguous motion through that virtual reality is 1 pixel of distance for 1 pixel of time, and that's the speed limit. That turns out in our reality to be the speed of light. And in the World of Warcraft or The Sims, it also has a speed limit as fast as you can go. Every virtual reality has a speed limit. So speed limits are not unusual. And so on and so go. I can continue with this, and I have about 40 of these mysteries in science, like why is quantum mechanics, probability based? Why is the speed of light constant? And there's a whole bunch more of those. And this model can explain all of them. So this is my basic take on consciousness. Consciousness is fundamental, and the physical world is virtual. It's a computed world. Now, why would consciousness compute a reality? Well, this is the other interesting part here. I hope you're with me, right? I'm not just
I'm with you.
going too fast or too far. You're with me?
Yeah, I'm with you.
Okay, then the next thing that's really important is that, why would consciousness do that? What's the point? Well, if consciousness is an information system, imagine that all the bits within consciousness are random. That means there is no information. Okay, now consciousness is conscious, so it can order some of those bits. And when it orders some of those bits, it creates information, and it lowers the entropy of the system. So an information system evolves by lowering its entropy. And that's true of consciousness. That's true of everything, even our physical evolution, from amoebas to human beings, evolved by lowering entropy. The human being is like 4 trillion bacteria all cooperating with each other to make a human. Well, they're all cooperating with each other. That lowers the entropy. So lower entropy comes through cooperation. And then this consciousness system realized that it could only do so much because it was one mind thinking. What it needed was some other minds that also had free will that it could interact with. So it took subsets of itself, which, let's say in computer talk, that's a virtual machine. Is that computes with you, a virtual machine? It's like a smaller computer inside a bigger computer. And it creates all of these subsets, and I call those individuated units of consciousness, and each one of those has free will. Now, eventually, they all go their own way, have their own experiences, come to their own conclusions, and now the possibilities for the system grow, because you don't have just one mind that's only limited to one mind. You got a whole bunch of minds that can argue with each other or have discussions or see things from different viewpoints. So that lowers the entropy as well. So now you have a social system of lots of pieces of consciousness, and that's what you are. You're a piece of consciousness playing Aaron Cohen, the avatar, in this physical reality that's really a virtual reality. So why is that? Well, first, let's go back to where I was. You're a piece of consciousness. You're in the system, and information systems evolve by lowering their entropy. Now, it's a social system. So how do social systems lower their entropy? Through cooperation, through caring, through working together, through having compassion for each other, helping each other. One farmer's barn burns down, everybody gets together and helps build him a new barn, because one more farmer making more food is good. So everybody wins that way. Now, the opposite of that is higher entropy. Higher entropy is random. Everybody doing their own thing in their own way. High entropy is fear. People don't cooperate. They're afraid that somebody else will get an advantage on them. If they have a new idea, they don't share it. They keep it to themselves for their own advantage, that sort of thing. So that's the fear side is high entropy. Consciousness evolves by moving toward lower entropy. So it requires the social system to interact with each other with caring. And I call that the love side as opposed to the fear side. So now we have this idea that what's the purpose of consciousness? Well, it's to evolve. And how does it do it? Like becoming kinder and nicer and gentler and more cooperative. And I wrap that all up into the word love, becoming love. So that tells us what our purpose is, why we're here, why you're playing this avatar called Aaron Cohen. You're supposed to make choices by which you move closer to becoming love. So it's not about acting kind, it's about being kind. And there's a very big difference between acting and being. So that's the purpose. So now you have the larger consciousness system, and it has all of these subsets of itself, like you and me. And these little systems need to make choices in order to lower their entropy. That's evolution. And as each piece lowers its entropy, the whole thing's entropy lowers because each piece is a part of the whole. So then that tells you why we're here. We're here to lower our entropy and make good choices. Choices on the side of low entropy rather than on the side of high entropy, on the side of love rather than on the side of fear. And it tells you why the virtual reality was made, because otherwise these pieces of consciousness would just be like in a big chat room. They could all communicate with each other, but there really wasn't anything very interesting going on. So you create this virtual reality where there are very significant choices have to be made, life and death choices, moral choices, important choices. How do you stay alive? How do you eat? How do you share? How do you work with your tribe and your group? And how do you deal with other groups? Do you fight with them or do you work with them? All these choices. So the virtual reality gives pieces of consciousness a great place to grow up, to learn how to lower their entropy by making significant, important choices. So now we have the purpose of the virtual reality, that you are a piece of consciousness playing Aaron Cohen. So what does that tell you, Aaron? That tells you that you're immortal. Your body is not. Your body will grow old and die, but you, the consciousness, will just find another fetus, another baby, and you'll start being the what we would call it, the player. You'll be the player of that avatar.
But when you say we're in a virtual reality, what exactly do you mean by that?
What I mean is, it's that the reality is computed. It's computed in a computer, just like any other virtual reality, just like The Sims. It's computed in a computer. But if you're in it, it feels real. Now, every virtual reality works the same way. So this virtual reality we call the physical universe, this virtual reality works the same fundamental way as any virtual reality. You have the two important components, which is the player. The player makes all the choices for the avatar. If you have an avatar in a virtual reality game and you don't make any choices, it just sits there and wobbles around. It doesn't do anything. All of its actions are you. You are its consciousness. You are its mind. You're the player. Okay. So now, if you are an avatar, so let's say you're an avatar, you're a character in The Sims. Well, where is the computer? The computer is outside of the virtual reality. The computer can't be inside the virtual reality. The computer has to be outside the virtual reality. And where is the player? The player has to also be outside the virtual reality. So if you are an avatar, your viewpoint as an avatar says that your player, your consciousness, is non-physical. It's outside of this reality because this virtual reality is what you call physical. And the computer that computes it has to also be outside this, what we call the physical reality, and that makes it non-physical. which makes sense because the player and the computer have to be in the same reality frame. They can't be in different reality frames. They're constantly communicating with each other. So then that kind of paints the whole picture of what consciousness is. It's an information system. What you are, you're a piece of that consciousness. You've probably heard the phrase, we're all one. And the purpose is to move toward love. You know, you've heard these. These are almost trite expressions, but they're all true. That is the way reality works. And with this understanding, you can solve all of the outstanding paradoxes in physics. They all make sense. Like, why is quantum mechanics probabilistic? Why is the speed of light, you know, a constant? All of those things. There's a whole bunch of those that fall out very, very nicely. Here's one that you hardly hear about, and that is that scientists know that the speed of light actually changes just a little bit in about I think it's about the 8th or 9th decimal place. It'll change. Now, we can measure the speed of light to probably better than 15 decimal places, maybe by now even 20 decimal places. So we know it's not error in our measurement, but it actually changes 8th or 9th decimal place. Not much, just a little bit. Maybe that 8th decimal place goes from a 3 to a 2 or a 3 to a 4, something like that. So why is that? And they've noticed that this has happened like 4 or 5 times. There've been these changes. Well, the speed of light is, like I say, is calculated as 1 pixel of distance divided by 1 pixel of time. That's the speed of light. Now, that also sets the resolution for the reality. That tells you how tiny the pixels are. Tinier the pixel, the more resolution. So a good simulation doesn't use any more resolution than it needs. If you're into computer science, you'll know if you're simulating something, you don't use any more resolution than you need to solve the problem you're working on, because more resolution means more computation, more things that have to be computed, more work through, you know, slower times, all of that. So our system's no different. So it doesn't use the maximum resolution, which is the delta x over the delta t, or Planck length over Planck time, which is the speed of light. It uses something much smaller than that. And then when we do things like build a big particle collider, you know, like we have over at CERN, well, now the humans are digging a little deeper. We're going to have to raise the resolution a bit, because they're digging deeper into the reality. So then they have to raise that. So it was maybe only, you know, 3 or 4 digits of significance in that speed of light for a while, and then it had to go up to 5 or 6. You know, we keep digging deeper and deeper into the reality. Now it's 7 or 8. You know, then next it'll be, you know, 10. And every time the system does that, it tries to keep the speed of light, the ratio of delta x to delta t, the same. So it would be handy if, let's say, you wanted to triple the resolution, then you could make delta x 1/3 as big and delta t 1/3 as big, and then your delta x over delta t would still be the same. But in a simulation, you're talking about digital information. You can't make those pixels exactly 1/3 smaller, because you fall off of 1 pixel onto the next. You know what I mean? So you have to take the pixel that's closest to the 1/3. And it won't be exactly 1/3 to 100 decimal places. It'll be a little different, because you move to this pixel, it's a little more. You move to the next pixel, it's a little less. So you pick whichever one's closest, and that's it. And the same thing with the delta t. You pick the pixel that's closest to the 1/3 that you want to raise the resolution. And now the speed of light changes just a little bit in the 8th or 9th decimal place. And we notice that. And that's an artifact of the fact that this is a digital reality, just like the speed of light is based on that. And that the system uses the fewest or the smallest amount of resolution it needs, and it has to change that resolution as we start digging deeper and deeper. So one would predict that the speed of light would change a little bit in the 8th or 9th decimal place now, because that's about where we live now. eighth or ninth decimal places takes care of almost everything we do. Probably 3 decimal places that almost takes care of everything we do. So see, these are some, I'm just giving you a couple of examples, but that goes on and on. So it tends to be a good theory if the way you judge a theory is by how well does it work? It works marvelously well. It explains all the attributes of consciousness. It explains all the paranormal things that consciousness can do over on the intuitive side. See, consciousness has an intellectual side and an intuitive side. The intellectual side is logic-based. The intuitive side is not logic-based. It's just information-based. It just gets information somehow. You know, that's your hunch, your idea that you just come up with, but it's not really logical. So you have both of those sides, and all the paranormal stuff actually happens on the intuitive side. But we don't develop that very much. We develop our intellectual side. You've been doing that now for many years, developing your intellectual side. But unless you're very unusual, you don't develop your intuitive side very much. Now, if you are very unusual, then you'll know that intuitive side can give you some very accurate, reliable information if you develop it enough. If you don't develop it, then the information's pretty spotty. You know, it's a gut guess, and you're wrong about as often as you're right. But if you develop it, it's just as reliable and just as accurate as what the logic can do. It's just different. It gets its information just by getting the information. It's not logically derived. So anyway, I've done a lot of talking. I wanted to just give you an overview of how that works and tell you that if you're trying to explain consciousness through quantum physics or through the the information field that's on the horizon of the black hole, then it's going about in the wrong direction. You're trying to take physical processes. Quantum physics is about physical processes, and from that derive consciousness, which is by definition non-physical. Consciousness is a non-physical thing. You can't build consciousness out of quantum physics. Quantum physics is created out of consciousness. You know, it's because it's computed through a rule set. Now, what's the rule set? The rule set's what we call physics and chemistry and biology. That's the rule set. That's what scientists do. They dig out the rules in the rule set. That's their job. So now I'm going to stop. I've kind of done a big data dump on you about consciousness and about my view. And I guess the last thing I will say is that if you look at this model, as far as how much does it describe? It describes everything. It describes everything in the physical world, in the objective world, and it describes everything in the subjective world. And suddenly, as a byproduct, you get a science of the subjective world. Why are some people happy and some people not? Well, this gives you a science of why that is. It's because they're not doing well at moving toward lower entropy. They're doing high entropy behavior, and that makes them unhappy and miserable. How do you become happy? You become caring and loving and helpful and courteous. That's how you become low entropy. So it tells you what's important. It defines right from wrong. Wrong is stuff that goes high entropy. Right is stuff that goes low entropy. So it does a lot of things, and it's very elegant. There's only one assumption, and that's that consciousness exists, which, since you and I seem to both be conscious having a conversation, that's not too big a stretch. And that's it. You take that one idea, consciousness exists, discover what is the minimal set of that consciousness. Consciousness, by the way, is just awareness with a choice. It's that simple. And then you do the logical evolution of consciousness, and you end up with just what I explained to you. So that's kind of a longer process, and I won't go through all of that. So it's more accurate than the physics we have. It tells a lot more also about the subjective world, and it's entirely logical. It's good science. Unfortunately, the way most people judge a new model is, how well does it fit the old model? How well does it fit what we believe? Yeah, and we believe in materialism. So if it fits a materialist thing, then we like it. If it doesn't, we don't like it. But judging a model on how well it fits our preconceived notions is not good science. That's bad science. So now over to you, Aaron. Ask questions. Tell me what you think. You think it's all crazy, or you
Um,
have the floor.
so when I went into this project with the hypothesis that string theory and the holographic principle could be an explanation for universal consciousness. So
Mm-hmm.
my original thing was that there may be a deeper layer of reality, a holographic layer, where
Mm-hmm.
some of our information is derived from, not just the brain, but from the holographic layer.
Mm-hmm.
And this could explain why people get similar ideas or thoughts at the same time without direct communication.
Mm-hmm.
And but it kind of makes sense because the holographic principle states that physical information is encoded onto the 2D surface, but why not
Mm-hmm.
consciousness and non-physical information? So when I spoke with leading experts in physics, I was surprised to hear a stern rejection. But do you think that there are any fields of study in theoretical physics that are at the mainstream university that have concepts aligned with your work, but they are calling it something different? Similar to how religion has come up with some ideas that overlapped with concept in your work, but they may call it something different.
Yeah. No, I don't think you'll find any in universities. You'll find them among individual physicists, but probably not courses in university. Now, there was a gentleman named Tipler. Tipler was a physicist. I don't know if you've come across his name. He was at several universities when I knew him. He was at University of Virginia, and he had a lot of ideas like this. And he did teach some courses at the University of Virginia when he was there. And so you'll find some scattered around, but they're more individual physicists rather than they are, university curriculum based. And that's because science is caught in what I call a belief trap. They have a belief that at the bottom level, matter, physicality is fundamental. That's what's fundamental. And therefore, consciousness, if it exists, has to be a product of something physical. So that's their going in. And trying to demonstrate how that works is what they call the hard problem. It's the hard problem of consciousness. How do you take physical, even physical information? How do you take something physical and turn it into something that is not physical, something that is ethereal, something that, how much does consciousness weigh? How much space requires, to put a piece of consciousness in? What's its volume? What's its weight? What does it do? How does it function? If you do that, you always end up with a machine, not a consciousness. It just doesn't work. The hard problem's been around, and people, scientists as well as philosophers, have been working on it for probably, 100 years or so. It's been a main topic, and they've made absolutely zero progress. Mm-hmm. Now they're working toward it. You'll find Hammerhoff and others looking for microtubules in the brain with quantum functions but that's back to the old thing that, if it flies, then, it's if a rocket flies, then it must be a bird. It's that thing that quantum physics has the right attributes to make consciousness. Therefore, there's a causal link between them, which is just not logical. So that's been the only place where science has actually tried to work on consciousness. And the people who do that tend to be kind of out on the edge, out on the fringe, and not particularly well thought of by their colleagues. It becomes a kind of a poison pill for one's career to go there. So most all the physicists there, that's a career for them. They're not just there as scientists trying to find out the nature of reality. They're there because they make a living and they support their families and their kids. So it's a job, and the job requires them to be materialists. Otherwise, they get pushed out on the edge and they're not very highly thought of. So you probably won't find that there. But what you will find are a lot of individual scientists who know that, one, reality is information-based. Now, what does logic tell you about reality being information-based? How can reality be information-based? How many ways can our reality be information-based? Well, there's really only one way it can be information-based, and that is if it's computed. It's, it is just information. The reality is information. So I can't think of any other way reality can be information-based, because you always have, if you go any other way other than consciousness, is the information system, and this is a virtual reality, you get into problems like, okay, there's information out in the field, and it's it's on the periphery of a black hole, or it's the
Entropy?
it's the holographic principle, and that's the information, and the information's on the surface. But where does the information come from? What's the source of the information? How does that information get there, and how does it turn into our reality and our ability to make choices, and where does all that come from? And there's a whole lot of questions about that sort of a theory that you can't answer. There are no answers for them, because that's not really the way it works. The only one where you can actually dot all the I's and cross all the logical T's, where where the information comes from. The information is what the consciousness is. It's an information system. And you have reasons for, well, why is it? How did that information get there? Why is that information there? How is it that that turns into us? And if that's the case, and this is this holographic principle, then what's the purpose? Why are we here? So there's just all these questions behind it. And if you just take the simple concept of consciousness is awareness with a choice, watch that evolve, go through the logical process of what had to happen for it to evolve, then you end up with the answer, being that this is a virtual reality, consciousness is the computer, and all the questions of how and why and what all fall into place. If you go with the whole holographic universe, yes, some of the questions get filled in, and it does it better than anything else. It's a good stab, it's a good try, it's a good theory, but it has problems. It has issues of, why is it there? Where did it come from? Where's the information come from? How does it get stored there? Who stores it? If that creates consciousness, then what am I? I'm a body with a brain, but how does my consciousness get here? And how does my consciousness work with that field? And who am I? And all these questions don't really have good answer that answers all the questions all the time. You can answer some of the questions some of the time, but you can't answer all the questions all the time. But the model that I described to you can answer all the questions all the time. So I'd say that the holographic universe is a good stab at it. It's got some appealing parts to it, but it has a lot of unanswered questions about just, how does that relate to me? How do I get here? Aaron Cohen, with my mind, my individuality, my purpose, whatever that is, how does it really relate to me? And that's hard to fill that in when you do that. And in my mind, going that way is a lot more complicated. You've got a lot more layers of complication to deal with. And in my model, there's very little complication. There's consciousness. It's an information system. You're a piece part of that, and you're in a virtual reality. It's very simple. It doesn't have a lot of parts, a lot of piece parts to try to get to you and who you are and why you think the way you think and what's your purpose here. It takes a lot of piece parts in a holographic universe. And in mine, it's a simple thing. And there's a thing in physics called Occam's razor that says, if you're talking about something that's fundamental, then it needs to be both simple and elegant. If it's not simple and elegant, it's probably not fundamental. So if your model has a whole lot of piece parts, well, here we could store data this way in this form, and that data can come and go, and our three-dimensional thing could be part of this two-dimensional, and you start trying to make all of the things like, why does the speed of light change in an eighth decimal place? Well, the holographic principle won't tell you that. Why is the speed of light a constant? Won't tell you that either. Why is quantum physics probabilistic? It won't tell you that either. So there's a lot of things a lot of details it can't answer, and it has a lot of complexity to it. Whereas my model is very simple, very elegant, and just has a couple of ideas. You get like take 2 or 3 ideas and follow the logic, and bingo, there you are. So that's what I'd say is the problem with that model. It's the same problem with Hammerhoff and his microtubules as a source of consciousness. And that's not a bad theory either. It seems to be, okay, quantum physics, non-local, consciousness, non-local. So he's trying to put that together, but it doesn't answer any of those questions either. Hammerhoff in his theory doesn't say why quantum physics is probabilistic. It doesn't say why the speed of light's a constant, and all the other, 30 or 40 things I've got that answer questions. None of them can do that. And they're very complex. You know the kind of complexity you have to have in quantum physics to produce this reality? The whole Earth and everything that's on it? That's a lot of complexity to do that. When you do it with evolution, it's simple. You have a set of initial conditions, you've got a rule set, and you push the run button, and there it goes. It just happens that way. And you end up at the end with something immensely complex, like our biosphere and all the creatures that live within it and all the interrelationships between all the creatures. Just even the human body, is immensely complicated. So how do you get immense complication? Well, it's a fractal process. Now, about, it's where geometric fractals. You know about geometric fractals. You get a little equation, and you just keep repeating it over and over in different scales, different sizes. And eventually you build a picture that's immensely complex, fine detail. You can get this very complex thing out of just a simple equation. Well, that's a geometric fractal. Evolution is a process fractal. Now, that's something else you won't hear anywhere else. It's a process that repeats itself. The output of that process becomes the input and goes back through the process, and you get a new output. You take that, put it back through the process, you get a new output. So the output becomes the input, and it goes through an evolutionary process. And that is the process that lowers entropy, because as you go through that process, you end up with something magnificently detailed, like the Earth and its biosphere and everything that lives here and doesn't live here. All the rocks, doesn't live, all the rocks and as well as the trees and the people and all the critters and bugs and algae and everything else all come out of that process, because it's a fractal process that as it goes round and round and the output becomes the input, eventually the result is hugely detailed and intricate at the level. So that makes good sense too. Our reality is part of this evolutionary process. Fractal creates this biology that we see, and biology is part of the rule set.
Yeah. In the big toe framework theory of everything, how big of a component is consciousness? Because it seems like there's a combination of random chance and combined with a guiding intelligence. So on one hand, you have possibilities and probabilities that are generated on the fly on a faster time latency than we can perceive. And then the concept of NPC characters entering the frame to save Johnny from the well, so to speak.
Mm-hmm.
Where's the intersection of intelligence overriding the random probability?
Oh, well, there is a process. How you ask the same question about The Sims, or the same question about whatever your favorite role-playing game is. If it's a virtual reality game, you could ask the same question about that. You have probability there. There's a certain probability that you'll come up with a spell when you open up that box. There's probability how things work, but there's also rules. You can't just flap your hands in the air and start to fly. If you're not that kind of creature that flies, well, you just can't do that. So you have rules, a rule set, and you have probabilities. Now, where that intersects and how that meets is a very interesting thing. And you brought up a very fundamental thing here, and that is, if you build a simulation from the bottom up, that is, you start with the elementary particles, and from those you make atoms, and from the atoms you make molecules, and that's what I mean by the ground up. You build it from the small things up. Then that's determinism. Everything is determined. If you know the state that everything was in before, you can compute what state's going to be next. That's basically physics, and it's deterministic. Now, if you have a probabilistic reality, how do you determine what's going to be next? Well, you don't know. You don't have all the states of everything before, then produce the next state. The way you determine what happens next is you take a random draw from a probability distribution of the possibilities. So something's going to happen next. You're a scientist. You have this big telescope. You're going to look out in some place nobody's ever seen before. There's probably 10,000 things that could be out there, and each one has its own probability. And it can't be something that is too different from what we know is in outer space. You know, it's not going to be something wild. It has to be constrained within what we already know. So the guy gets these big, brand new super telescope. He turns it on, and the system that's computing this reality takes a random draw from a probability distribution of all of those thousands of possibilities, and each one has its own probability. Now, when you take that random draw, that doesn't mean you're taking a random draw from the possibilities. You're taking a random draw from the probability distribution of the possibilities. So the things that are more likely are more, the things that are more likely to happen are more likely to be drawn out that way. So I can explain that more if you want, but in any case, so that's how you find out what happens next. So here's all these possibilities. This one has a 0.5 probability. If this one has a 0.00001, and it takes a random draw out of that, and it's more likely to get the one to 0.5, but it could just pull out that 0.0001, and something really strange is going to end up there. Mm-hmm. Or most likely it's going to be something that kind of looks like what we already know is going to end up there. So this is how the system determines what happens next. A simpler thing, and it affects everything we do. If you go out into your backyard at home and you dig a hole, what are you going to find? Well, the probabilities are high for finding dirt, for finding rocks, for finding, plant roots. Those kinds of things are pretty high. But let's say you live near the Gulf Coast, you'd have a certain probability for a gold doubloon because that's where a lot of traders were that were trading in gold. Now, if you happen to be in Arizona, then you're not likely to find a gold doubloon there because that's not part of that history. So that probability would be the 1 in the 100,000 that somebody from around the Gulf Coast traveled to Arizona and lost a doubloon there. In your backyard, you might find your grandfather's pocket watch. Who knows what you find? But there's a probability for all of these things. The random draw, that's what gets rendered. So you see, this is how probability and the reality kind of meet. That's how the new thing, when you make a measurement, that's how what you get comes out. It's that random draw. When you do the double slit experiment, where that particle hits the screen is a random draw from a probability distribution. And that probability distribution looks like an interference pattern. So when you take random draws out of that pattern, you end up reproducing that pattern if you don't have any which way data. So that's how reality works, and that's the intersection of probability and rules. So you have rules, that's the rule set, the physics, the chemistry, the biology, that's the rule set. Then you have evolution that has to evolve according to those rules. So now, for instance, you're a piece of consciousness and your avatar has an accident. He's in a car accident, say, and your avatar loses its memory, can't remember who he was, and he slurs his speech, can't speak very clearly anymore, and he drags his left foot when he walks. That's a result of a brain injury. So you'd say, the brain is important here. No, the brain isn't. There is no brain. Brains aren't computed because they're inside your head. They're only computed if somebody opens your skull. There's no point in computing things that nobody sees. So what it is that injury, you look at the rule set. What does the rule set say about somebody who has this big chunk of his brain missing? Well, what the rule set says is you can have these various conditions and probability. One of those gets drawn out from a random draw, and that's the way that person is. And you're the consciousness playing that person. It doesn't hurt you any. Your consciousness is just fine, but now it has to play a character according to the rules of the rule set. So it's now a piece of consciousness playing a player that slurs its speech, drags its left foot, and can't remember. So now it has that problem. So you see, that's the way it works. So the physical world is a representation of the rule set. And there's chance involved because everything is a random draw from a probability distribution of the possibilities. So we have randomness built into the system, but the system has rules that must be followed. So that randomness has to work within the rules. You can't just go outside, flap your arms and say, I want to fly today. It won't work. Your body's too heavy. Your hands are not big enough, and you can't flap your arms that fast. So the rule set prevents you from doing that.
Yeah. Do you see the quote unquote mainframe computer that's running our stream of everything as something that is physical somewhere that would be perceivable in the observable universe?
No, it's not physical anywhere. Consciousness is not physical. It's just consciousness. Consciousness is awareness with a choice. Okay, the simplest form of consciousness would be a single awareness that had the ability to discern that it was in state 1 or state 0, or A or state B, a binary. That's the simplest form of consciousness because it's aware. It's aware that it can be in 1 or 0 and has a choice. It can choose which one it's in. So that's the tiniest piece of consciousness you can have and still call it consciousness. Now, that is a binary, and it, through its memory, can remember what it was last time and what it is now. So in its own memory, in its mind, so to speak, in its consciousness, it can have patterns of 1s and 0s. Or you go the other route and you can say, well, it duplicates itself, just like cells did. Single cells, then there was multiple cells. And those multiple cells work together to make a multi-celled creature. You had amoeba as a single cell, and then you get a jellyfish, and it's got probably millions of cells. And the cells are differentiated. They do different tasks, different things. So through evolution, things build up and get more complex. And the more complex they get, the lower the entropy is, more survival they are, the more choices they have. So no, that's consciousness fundamentally is just awareness with a choice. And if you ask me, well, where does the awareness come from? I can't say that because we are consciousness. We're inside a consciousness system. To know where the system came from, you'd have to be outside of our system, outside of consciousness, looking at it as an independent thing. But because we're a piece of it, we can't get outside of ourselves to look back at it. So it's not that there's an infinite regression. Oh, consciousness, A came from B and B came from C and C came from D, dot, dot, dot to infinity. It's not like that. You just say, can't tell, don't know, can't know. It's logically impossible to know because we can't get out of what we are to see where we came from. Yeah. The only way to see where you come from is to get out of who you are and look at it from an objective viewpoint. So the idea that I can't tell you where consciousness originated, I can do some good hand-waving arguments about it. And if you're interested in those, you can go to the philosophy department and look up the game of life, cellular automata, and they will then take cellular automata and the idea that if you have a possibility, eventually those possibilities will happen. If there's something possible, sooner or later it will happen. That's also it's a statistical math thing. And they put those two together and come up with how consciousness was born. But because we can't get outside of ourselves, it's speculation. It will never get past the point of speculation. We're stuck there. And it's not because we're just not smart enough. It's because it's impossible to get outside of who we are. So that's why I start my thesis with consciousness exists, because I didn't want to start with speculation. That's a weak start. So I just start with, okay, that's an assumption. Consciousness exists. Now, the opposite side of that, well, let me tell you this. If consciousness exists, then time and free will has to also exist. Time, because you have before the choice and after the choice, right? Even if it has a choice, then you have to have time before the choice and after the choice. And if it's free will, it has to have free will because otherwise you don't have choice. There is no choice without the freedom to make a choice. So consciousness, free will, and time all are logically necessary for each other. You can't have any of them without the others. The opposite corner of that, the complete opposite of that, is materialism and determinism. Now, if you are a materialist, you have to be a determinist, because that logically follows from materialism that you're a determinist. If you're a determinist, then there is no such thing as learning. There's no such thing as evolution. There's no such thing as time. There's no such thing as consciousness. And there's no such thing as free will. There's nothing. Nothing happens. Everything is fixed. It just is. Nothing goes, nothing comes, nothing changes, nothing learns, nothing evolves. It just is. Well, that's kind of the null set as far as, looking at reality models. That's like a nothing. Nothing exists. It's all there, period. Nothing else can be said about it. That's kind of the null set of ideas of the nature of reality. It doesn't go anywhere. But those two opposite corners, if you're in the opposite corner with the consciousness and free will and time, then you see the physical reality as an illusion. If you're into determinism, you see consciousness and time and free will as an illusion. Those two sets are incompatible. Now, a lot of people who don't understand that, they have one leg and, one foot in both camps. They say, yeah, I realize that there's a spiritual dimension to things, and I realize that consciousness is non-local, but I'm a materialist too, and da. Well, they have a foot in both camps, and that's illogical. Logic says you have to pick one or the other. They're mutually exclusive. You can't have a foot in both. So that's a point to keep in mind. Well, you have some more questions for me there, so go ahead.
Well, I'd like to show you my MLHC research paper. So, in it, I propose that quantum information in black holes isn't stored uniformly on a single surface, but rather across multiple nested layers. So, this multi-layered approach not only refines our understanding of black hole entropy, but might also hint at a deeper implication for the nature of consciousness. Would you be interested in taking a look at my research paper and its accompanying simulations?
I think that would be very interesting. And I think you've got a good choice there, because by adding multiple layers, you add the flexibility of the system. The system isn't just, unifunctional. You got multiple layers, and that multiple could be like 2, or it could be 1,000,000. It's got multiple layers, and that allows for a much richer ability to produce output, because you have multiple things going in. So I know a little bit about the holographic principle and those ideas. So I applaud you're going to multiple layers. I think that's a step in the right direction.
Yeah. So, would you like if I shared my screen to show you it briefly?
Sure. Go share your screen.
Okay, so I'll read you the abstract. So I propose a novel framework, multi-layered holographic compression, or MLHC, that re-examines the encoding of quantum information in black holes. Traditional holographic models treat the event horizon as a uniform single-layer boundary. In contrast, MLHC posits that information is hierarchically encoded across multiple nested layers. I present a rigorous mathematical formalization of the framework, introducing variable layer radii, exponential compression factors, and a refined entropy distribution. I also analyze the time evolution of black hole properties under Hawking radiation and explore implications for rotating Kerr black holes. Numerical simulations support the MLHC model and suggest new insights into black hole thermodynamics, quantum gravity, and the information paradox. So,
I see kind of where you're going with that. Like I say, I like the idea that you do multiple layers. That gives the result more possibilities in which you can fill, because those layers can interact with each other. Like you say, they're one's layer inside the next.
Yeah. It's like an onion.
That's good. Yeah, I think that's probably a good way. And I suspect that idea is probably does will probably work for you. I think that the people who are working those sorts of things probably would find that an interesting idea, and they'd want to question you on where the multiple layers may be coming from, or why they're there, or you just positing them that they're there, and then so see what you can make of it. If it does have the layers, it's probably where you're coming from. I think it's good work.
The framework is as follows. I use some formalizations from other theories as well, and they all come together to create MLHC. But my favorite part is the numerical simulations. So there are two here. This one shows a Kerr black hole with MLHC layers, and this one shows energy and entropy dynamics across time. So click on this, you can, if I run this, and it's interactive, so there are different parameters the user can adjust. So here is the model of a 3D Kerr black hole, and here is the MLHC entropy field, the layers. So if I adjust the mass, as you can see, the mass of the black hole gets much larger, and the outputs change. And these outputs are derived from equations I inputted into the code to make it as scientifically accurate as possible. So I recently, if a black hole's spin is at 0, it's perfectly round. But if you adjust the spin, the black hole gets smushed. So I found that interesting.
Yeah.
And adjusting the layers is as follows. It just it represents that there could be more layers inside of a black hole. And if you adjust the sharpness, it makes each of those layers brighter and this represents more information inside those layers. So that's the Kerr black hole with MLHC layers simulation.
I think it's well done.
Thanks.
I think it's very well done. And if you follow things like this, you're going to learn a lot. You know, more of this kind of thing you do, the more you're going to learn. You know, in the big picture, I would say that, you know, there's, you know, if I were looking at this having to do with a model of consciousness, I'd say there's too much complexity. There's simpler models that are more elegant that you can get there. But that doesn't mean you can't get there, you know, from other models. It just means they're more complex. So you have more, it usually takes more assumptions to prop them up. Like you have to make an assumption about how fast is the thing spinning and what the layers and how many layers there are and the different way that the layers interact with each other. And so you come up with a lot of assumptions to explain it. And then those assumptions have to somehow be related back to the real world. What do these assumptions mean when translated back to the physical world? So that's difficult. The more assumptions you have, the harder it is to make each assumption a believable thing based on how the real world works. So it's very daunting to take this and keep pushing on it. But whether this turns out to be some brilliant new innovation or not isn't the point. It's a great thing for you to be doing to learn, to push your own mind into new spaces. So I would not worry too much about the final outcome of where it goes, but use your mind to make this logical, make it rational, make it make sense. Have a story about the various spins and what that does and how it affects what we measure. So that's the challenging part, to just come up with some complication that has possibilities. Well, that's like the first thing you do. But then the next thing you have to do is all those possibilities have to be related to the physical world somehow. Or if you are doing something with consciousness, to the non-physical world somehow, because there is a non-physical world, which is called consciousness. And we avatars in this virtual reality, we think our virtual reality is physical. All avatars think the reality they live in is physical. And so the source always has to be non-physical from the perspective of the avatar. So you have to also look, when you do this modeling, you'll have to look as how does it play with consciousness as a non-physical player in, in your model. What does your model say about things that are not physical? Because consciousness cannot be described with physical terms. You can't say, how much does consciousness weigh?
Yeah.
What's a gram of consciousness? How much volume does consciousness take up? It doesn't have the properties of being physical. Can you put two consciousnesses in the same spot? None of these things make any difference. Consciousness is just an information system. It has no distance. The way you create distance, the way you create length, is by arbitrarily picking a point and then dividing, if it's a three space, dividing three mutually perpendicular unit vectors. Now that defines three space plus infinity to minus infinity in all directions. So that's how you create space in a virtual reality. Now, time, you don't create. Time is part of the fundamental process in that virtual reality. It's the delta t. If you're modeling, you obviously are doing well with MATLAB here. If you're modeling, then if the model's dynamic, then you have to have a delta t that progresses motion. So that's the pixel of time, if you like. So you'll have to decide how all of this, how it works dynamically. What are the dynamics of it? If you're modeling things, what's your delta t and what moves and doesn't move and how does it change and why? So what you've done is tremendous. I applaud you on the thoughts, and I think your idea about doing multiple layers is a good idea. And it sounds like a project from which you will learn a lot. And that's the point of all projects.
Yeah.
You don't start a project with the idea you're going to win the Nobel Prize. That'll just drive you crazy. You start a project with the idea, what are you going to learn? And I think this has great learning potential for you. It already has. And obviously you've become a pretty good MATLAB programmer as well in the process, because it's nice that you have these charts, you can modify your variables and see how they make changes according to your equations. That's pretty cool. If you come to my CUSAC site, I don't know if you've ever been to that site, cusac.org. If you go to that site in another few months, I hope, I will have the quantum physics set up just like this, like you do in MATLAB, where all the variables in quantum physics are available to you. And you can modify, say, a double slit experiment with every variable that you have and see the difference in the output and how it works and what you get. It's just like this. It's going to be kind of a tour de force of basic quantum physics at this site with graphics like this. It's not quite ready to go up yet, but in the near future, it sounds like something that you'd like to play with, because you get in there and you can vary the slit size and you can vary how far apart they are and vary the wavelength of the light. And you can vary all those things and see what the quantum physics says about what happens.
Yeah.
It's a fun toy. So every once in a while, go check cusac.org and you'll hopefully we'll have that up under the experiments section. I have a bunch of quantum physics experiments that I've done a couple. I've got two more that I'd like to do that I think, if they work the way I predict, they will have a pretty big impact in the physics world, because they will demonstrate that that this is a virtual reality and the consciousness is a computer. And when I say demonstrate, it means it lends evidence to that. Science doesn't run on proof. Science runs on evidence.
Yeah.
So this will merely point to some evidence. Well, this is pretty neat. I think you've done a marvelous job with it. And just keep going working on it, because everything you work on, you'll learn from it. You'll learn a lot of things. And a lot of the things you learn won't have anything to do with the science. Some of it will just be stick-to-itiveness. Some of it will be better programmer. Some of it will be, developing new concepts and ways of thinking about things. So it's all very useful. So good job. Keep it up.
Yeah, I've also, I have one more simulation for this.
Oh, good. Let's see it.
This simulation represents the time evolution of things like entropy and energy density. So
Mm-hmm.
You can adjust various parameters and it changes the visuals
Mm-hmm.
with, again,
And
inputted scientific
mm-hmm.
equations to make it as scientifically accurate as possible.
Mm-hmm.
So yeah, I made this one pretty recently too. Um, but and I've used various references for this research paper.
Mm-hmm.
So yeah.
That's good. That's good. Yeah, for most of my working life as a physicist, I was a non-academic physicist. I was out in what I call the real world, not the academic
Mhm.
world. And in the real world, you have to solve problems. You know, people have problems that they have trouble understanding how something works or what the possibilities are and the probabilities. And that's what I did is I modeled large complex systems in a computer. That was kind of my forte. So I would, I worked for NASA for a while and modeled the Ares, which was going to be the follow-on to the shuttle. And I did a lot of risk analysis with it in my programs. But
That's cool.
I like what you've done here, and it's good to do the graphics with the math. That really helps you understand how things interrelate to each other, how changing one variable moves through the system.
Yeah.
That's good. Yeah. So what you're doing is kind of what I did for a living for many years is that kind of stuff, except on really complex complex systems.
Yeah.
Yeah, worked for the Defense Department some, NASA some, and Boeing some, and Teledyne Brown Engineering some, a lot of different engineering companies. My last part of my career was as a consultant, and I encourage you to become a consultant as early age as you can, because you'll get all the fun work and none of the drudge work.
Yeah.
And you'll only get hired by people who can't solve a problem themselves. So you get all the interesting work as well and the challenging work. And you should look for a career that is fun. Not just, I can tell you're having fun with this stuff, doing
Yeah.
the graphics and all of that's fun. Stick with that. Fun is the way to go. I always found science and physics and math and modeling and computers to be fun. So I probably was a lot like you when I were your age, except I didn't have the tools that you had.
Yeah.
when I was your age, there were no personal computers.
Yeah.
So anyway, it's good. Keep having fun. Keep thinking up new ideas and what their logical consequences are. That will hone your mind for bigger things as you grow. Great.
Yeah.
Keep working at it. You're doing great.
Thank you. Yeah, have you heard of the telepathy tapes
Yes,
the Hip
I have
podcast?
heard of the telepathy tapes.
Yeah, so I know
Mm-hmm.
you spoke about having had success in the area of remote viewing and being
Mm-hmm.
able to describe targets pictured in photographs
Mm-hmm.
or in geocoordinates, and
Mm-hmm.
that you were able to pick out faulty cards out of a huge stack because they appear the color red to you.
Mm-hmm.
So have you seen anything that's beyond that, such as someone who can read minds consistently? Is there any physical element to these capabilities, such as telekinesis?
There's not to those abilities. Telekinesis is one of those abilities, and I can tell you how they work. I can tell you, why they work, what the parameters are, what you can do with them, what you can't do with them. So yes, one of the rules in this model of mine is that all pieces of consciousness are on a net. We're all netted. So your consciousness and my consciousness and your dog and cat's consciousness, we're all netted, and we can trade information with each other, and that's telepathy. And now the reason that in the telepathy tapes that the children who were able to do this were autistic children. The reason autistic children are better at this is because their logical mind doesn't work very well. They have a hard time dealing in a world that's rational. They then have only that intuitive part of their mind that they can develop. So they do develop it. And they develop that intuitive part much greater extent than do most adults ever develop their intuitive part, because most adults only try to develop their intellectual side. So these kids develop those abilities. And yes, every consciousness is netted. One can read the thoughts of another. One can send another messages. One can get data out of what's called the databases that exist in consciousness. And those databases exist because they're necessary for the rendering engine in consciousness to create the virtual reality. That computer that creates the virtual reality needs some data about the virtual reality, and that's what that database is. So you can go there with your intuitive side and pick data out of the database. And there's one other interesting thing about what you can do with your mind, and that is because what happens next, and because, the way probabilities drive this reality, as I told you, it's a random draw from the probability distribution. Well, you can use your intention to modify those probabilities. So you can use your intent to make a probability be less or be more. So when that random draw is taken, you'll get a little different answer because of your intention. And that's what people use to say, heal someone or do telekinesis. It's that modifying future probabilities. That's the key thing that you're able to do. And the reason we can do that is that's a feedback mechanism for consciousness. Consciousness is here. This is a entropy reduction schoolhouse where we are in a simulator to reduce our entropy. So it's an entropy reduction simulator. Just like there's flight simulators to teach people to fly airplanes before you put them behind the controls of a $100 million aircraft. Mm-hmm. So it's the same sort of thing. But yes, all those things do exist. The idea that you can affect things with your mind, you can change the probabilities. And now you can't get everything you want, because if the probability is 1 to 1,000,000, you may change it all the way down to 1 to 1,000. Wow, you're very strong, but you're still not likely to get it, because 1 to 1,000, isn't going to happen. So you can't just get whatever you want. You can't just manipulate the system, but you can affect it in some ways, depending on the strength of your intention, how much noise is in your mind, and all of these things, the clarity of your mind, the stability of your mind. And people tend to develop this clarity and stability through meditation. But that's not the only route. There are other routes you can go to develop that too. You can develop it through imagination. So all those things are real. Yes, that's why the kids with autism are better at it than others, is because they're stuck with nothing but an intuitive mind to work with. So they just naturally develop it, and they can tell what mom's thinking and that sort of thing. There are people, if you go to the Cusack, you see that it's really easy to teach children how to, what do they call it, read without eyes. They put blindfolds on them and make it so they can't see anything, but teach them how to read. They can put a book up in front of them and read what's on the book with no light. Put them in a room that's totally dark, completely black, and they can still read the book. Put the book in a different room, and they can still read the book. All they're doing is doing remote viewing in real time, rather than remote viewing at a particular place. It's their remote viewing where they are and what's going on around them. So all these things are well known. There are savants that can do things like, what's the cube root of 325,682? And they will tell you the cube root of that in 5 seconds. Mm-hmm. And they'll just read off the digits. What's the fifth, prime number? What's the next prime number after that? And they'll just read off, 10 digits of it. Well, they're not computing it. They're just, in their mind, they see the answer. That's what the intuition can do. It just gets information. And the information is valuable because it's needed to run the simulation. So it's there in a database. And you query the database with your intent. So all those paranormal things are actually real things. And they're all done through the intuitive side of one's consciousness. And what's best for people is to develop both their intuitive side and their intellectual side and let those work together, because they do very different things. And sometimes the intellect is the best tool, and sometimes the intuition is the best tool. And if you have both of them developed, then they work as a team, and you end up with a much larger decision space. You understand things much better. But most people have an intellect that's been pretty well, honed and polished and developed, and an intuitive side that's not even as good as it was when they were 3 years old. 3-year-olds are pretty intuitive. They know a lot more than what you think. They don't have language to explain what they know, but they know a whole lot more than people give them credit for. They're aware of feelings and attitudes and other things that they just get intuitively. But then by the time they're 7 or 8 years old, they are told to forget all that. That's nonsense. And then they stop developing that intuitive side. And by the time they're 30 or 40, their intuitive side isn't even as good as it was when they were 3.
Yeah.
So all those paranormal things are real things. And if you go up on the web and study them, you'll find there's lots of people who have studied them very precisely with very strong scientific protocols. It's not just a bunch of people, having fun and making stuff up. There's that. You get a lot of that too, but you'll find some good science there. There are people who are very careful in their protocols doing these things, and they're not all, fakes. Most of them are not. Most of them are real things that are actually happening. That's the beautiful thing about consciousness and mind. It's not limited just to the objective world. There's a subjective world that is actually more rich and more varied than the objective world. It's sort of like this. If you go to a play, you don't go there to watch the props. That's the objective stuff that's on the stage. You go, and it's not even you go to see the actors' bodies. That's also objective world. You go because of the things that the people say, the actors say, because of the interaction between the characters, because of the plot line. Well, all of that's subjective. So the subjective world is actually a richer, more interesting, more valuable world than the objective world. The objective world is just the stuff. The subjective world is all about what that stuff means and the significance of it, and the significance of your relationship to it and it to you, and your relationship to other beings. And all of that is in the subjective world. Things like, justice and fairness and all that, it's all subjective. That's not part of the objective world. But those things are important. Beauty is all subjective. So the subjective world is a very rich, colorful, and wonderful place to experiment and work. And scientists, unfortunately, give that all up and say they're only interested in the objective world. It's like going to a theater and say, I'm only interested in the props. Let's study the props. Let's forget the actors in the play. Let's just study the props. So a whole bigger science has to take in, a real theory of everything has to take in the subjective as well as the objective world. If you're only creating something in the objective world, then you're limiting yourself to that part of reality that is the least interesting. It's still important, but it's not the most important thing. So I'd say as you grow up, be aware of the subjective world as an important part of your life. Don't dismiss it because it's not objective. It's also very important. And you can develop that subjective side as much as you put effort into doing it. So I think you're doing a great job. I read a little bit about your school that you're in, and it was like, wow, that's great. Because I was one of those kids too, that had a hard time fitting in and a hard time relating to my peers. I got along the best I could because I didn't have such a school, but I think it's amazing that you do. And it really gives you guys a leg up being someplace where you're actually appreciated and understood.
Yeah. But looking ahead, what do you believe are the most promising areas of research or technological advancements that might help us better understand the nature of consciousness?
Well, looking ahead, and I guess this is really coming from my, just my viewpoint, but looking ahead, I see that this theory of mine, which is a toe, an honest to goodness toe, it's a theory of everything. It's the objective and the subjective, that eventually it will catch on and it will replace the science that we have. And the reason I think that's likely is because the physicists and other scientists that have come and understood my model generally like it and become supporters of it. Those that don't know anything about it, of course, they're very critical of it and think it's a lot of nonsense because it doesn't fit with their beliefs in materialism. But those that do look at it almost always say, oh, that's a better description. And I think that will one day, it will kind of be accepted as the nature of reality. And when that does, also the big thing that's going to happen is when you have materialism as your fundamental idea about reality, there's an ethic that comes along with materialism. Materialism is about the stuff. And the ethic is, well, look, there's all that stuff out there and it's for the taking, and whoever takes it and keeps it, owns it and can use it. And it turns in that the ethic of materialism is control, power, and force. That's the ethic of materialism. There's stuff and you want to control it. You want to have power from that control. And usually that takes force to get the control and the power. So that's the basic ethic of materialism. The ethic of my model is caring, sharing, compassion, kindness, all those things are the ethic. So if our world takes this model as better science, which I think it will one day because it is better science, it just answers more questions and it's simpler than the competitors. If that happens, then the ethic will change and our world will stop being so rowdy and mean and grabby and violent, because people will realize that that doesn't get you anywhere. That's counterproductive. That's high entropy behavior. High entropy behavior is de-evolution, not evolution. You need to evolve as a consciousness to lower entropy, not de-evolve into higher entropy. And if we can change the basic ethic that humanity has, this place will be changed radically. It'll be a much kinder, gentler place to live, to work, to raise your children. And science will expand greatly with the new understanding that doesn't lock it into materialism. Science has been locked into that mindset since Newton, and it's time they outgrow it. Quantum physics showed them that Newton wasn't right. It's all about information. That information is probabilistic. And scientists have been trying ever since to turn quantum physics into a material science. And of course, it isn't. It's a probabilistic science, and reality is information and it's probability information. So anyway, I think that is going to be the next really big revolution in science. Is going to be a whole very big shift in paradigms away from materialism and determinism and toward toward love, toward caring, toward kindness, and seeing reality, our physical reality as a virtual reality. That solves so many problems that are mysteries now, that I think that will not only fix a lot of problems in physics and philosophy and theology, but it'll also change the ethic by which humans interact with each other. No, it's not going to do that fast. I'm talking decades at the shortest. It's not going to be real quick. But I think that's the future. And that's going to be the big paradigm shift. But right now, that paradigm shift is so large. It's such a big step for people to take from materialism to this is a virtual reality and love is the reason we're here. That's such a huge paradigm shift that most people have a hard time wrapping their minds around it. It seems fanciful. It seems wild and crazy. It's just too far out. Well, the fact that the Earth was round seemed really far out a long time ago.
Yeah.
People said, well, it couldn't be round. Of course not. If round, everybody on the other side would fall off. All the water would drain out of the oceans and run over the side.
Mhm.
You know, it just doesn't make any sense that it's round. Well, that's because there was one thing that was missing in their understanding, and that's called gravity. So, you know, that's all they thought first that the Earth was the center of the universe, you know, and of course that collapsed. And there's been all these paradigm shifts through philosophy and through science. And if you take all of those and multiply them times 100, that's how big this new paradigm shift is going to be, because it won't only change science, but it'll change everyday thinking, everyday understanding of problems. People will know that their intent can modify reality. People will know that's why the placebo effect works. It's because the mind modifies probability, and what happens next is probability based. So it just explains a lot of things. You know, you put a little pinwheel up on a balance, and you use your mind to make the thing. You've probably seen that, you know, to make the thing rotate. Well, that's because your intent is modifying the probability of what the air pressure is on certain sides of that little pinwheel. And what the air pressure is there is a random draw from a distribution of probabilities. So you can change those probabilities, you can change the air pressure, and the little thing goes around.
Yeah.
Now take that same thing and put it in a vacuum, you know, a vacuum jar, stick a big jar over it, pump all the air out. Can't do it anymore. Oh, you know, so that'll tell you it's about the air pressure. So there's lots of limitations that also are involved in doing things that are paranormal. You can't do everything with it. It's a real thing, like anything else. It has its things that you can do and things you can't. But
Yeah.
they're all real. But no, people will shut you down. They'll say, no, that's not the way it works, because you're thinking a little outside the box. Your multiple layers are outside the box. You're trying to associate that with consciousness is way outside the box. And when you talk to other physicists, you'll find that almost to a T, they are all inside the box.
Yeah.
They are believers, and they believe in materialism, and therefore the things you're doing couldn't possibly be true. So that's just the way it is. That will change. That will change. People like you in another, 15 to 20 years will be the scientists, in charge, and you will have bigger viewpoints because you'll have grown up with more data than they grew up with. When they grew up, there were no, telepathy tapes. Those things didn't exist. You're growing up in a time where a lot of these things are coming out. Before, that would never be published. You go back 100 years and something like that would say, nah, that's nonsense. We can't publish that. Nobody will believe it. So they just weren't published. So these people that are in those positions now in science and philosophy and other places, they had a very limited exposure. You're getting a lot more exposure. You grew up in an internet world where you can see what's going on all over the world. You run into people like me on the internet. You say, expand your possibilities.
Yeah.
And the other thing I would leave you with is stay skeptical. Be skeptical of everything. And the person you have to be most skeptical of is yourself. Always be skeptical of everything, including you, because we humans are really good at finding the things that support our beliefs and throwing away everything that doesn't support our beliefs. And then we're stuck in a trap. So good work, Aaron.
Thank you. Well, thank you so much. I truly appreciate your willingness to explore these deep questions with me, and I'm excited that I was able to share my MLHC research paper with you.
Mm-hmm.
I hope our conversation today not only helps me further my work, but also inspires others to begin asking these important questions about consciousness. So
I hope it does too. And the reason I'm here, it's not because I'm not busy. I'm really busy. I got a very tight schedule. And you got squeezed in around a whole lot of other things that didn't make it. But that's because young people are, as always, the future. Young people are the fresh minds that can see bigger pictures. And young people are important. And if the system of education doesn't give you bold new ideas, things to be skeptical about, then where are you going to get them? Well, you get them these days from the internet. And I want to encourage that. So young people like yourself who are out there at a very young age thinking big thoughts, I couldn't pass up the opportunity to chat with you a little bit and get a sense of where you are and see your work and give you kind of another whole set of possibilities to be skeptical about.
Yeah.
And to think about, not to believe. You don't want to believe anything. Don't believe anything I tell you. You got to find out for yourself. It has to be your experience. You have to be skeptical of everything. So as long as you're skeptical and as long as you're open-minded, you'll do really well. You'll end up in a really good place doing things that other people need.
Yeah. Well, thank you again for your time and insights.
It's my pleasure.